Hello, welcome back once again. Today we have an indefinite integral problem, and remember in the previous video I uploaded on advanced series, I integrated this without even showing workings. And remember I told you guys that in the next video, which is exactly this video now, that I'm going to show you guys how the arctangent of x is integrated with respect to x, right? So here we're going to start. Now we have I equals this arctangent of x, right? So I can rewrite this as I equals the integral. So I can say 1 multiplied by the arctangent of x dx. So I have reason for this, right? Okay, now in this video we're going to make use of the integration by parts techniques, right? So we're going to first call u equals the arctangent of x. And I'm very sure we're very familiar with the derivative of the arctangent of x, which is exactly equal to 1 all over 1 plus x squared, then dx, right? Okay, now our v here is going to be equal to something that when we differentiate it, we're going to have 1, right? So our v here is going to be the integral of this one right over here, and the integral of y is x, right? So we have here x. Then when you differentiate x, we're going to have this one right over here. You need to take note of that. Anytime we are going to make substitution like this, u equals something like I started with u equals the arctangent of x, and here the derivative gave me this, right? And here what we're going to call v must be something that when you differentiate it, you are going to have 1, which you are seeing right over here, right? So here the v is going to be the derivative of x, that is going to be just 1 dx, which is just dx, right? Okay, so the integral we called I in terms of u and v is going to be uv minus the integral of v du. And this equals uv is x multiplied by the arctangent of x, then minus the integral v, our v is x, multiplied by du. Du is exactly 1 all over 1 plus x squared dx, right? So here we have 1 all over 1 plus x squared dx. Amazing, right? Okay, here our I equals x multiplied by the arctangent of x minus, here we have the integral x divided by 1 plus x squared dx. Now look at the trick. We have x times the arctangent of x, then minus, here if I should have 1 all over 2 outside, we're going to have 2 inside, right? Because 1 over 2 times 2, we're going to have 1, right? So remember we have x here, then divided by 1 plus x squared dx. You know why? Let us recall this property of indefinite integral. Remember, when we have the integral of f prime of x divided by f of x dx, this is exactly equal to the natural log of f of x plus c, right? That is the function here. When the numerator is exactly the derivative of that function, then the answer is just simply the natural log of that function of x. And take a look at this integral right over here. The derivative of the bottom here, which is 1 plus x squared, will give us exactly this guy right over here, which is 2x, right? So here we have I equals x multiplied by the arctangent of x, then minus 1 all over 2, that would be the natural log of 1 plus x squared, then plus c. And this is the right answer. Thank you for watching. Please kindly subscribe to my channel. Also like, comment and share. Bye bye.